the topic Dean's going to be talking about in terms of bring your own spectrum, but also neutral hosting, and it's been a theme within TAD Summit for many years. Normally what we'd have is Mr. James Bodie stand up and do a dangerous demo to prove that using open source we can do everything in terms of this topic. And then we would have Dean do a presentation that focuses more on the practical realities and opportunities. So we don't have James. He's been tweeting. He's sadly missing us. He wishes he was here. But he's busy with his startup at the moment and Chalk Mobile. So I think they were on the news recently in the UK, which is good to see. So what I'll do is I can see we've got most of the people here now. So I would like to introduce Dean, who's been with us since the beginning with TAD Summit. So thank you so much, Dean. And over to you.
Thanks, Alan. And yeah, no, I've been a pretty regular attendee at almost every TAD Summit. I didn't come to the KL one you did this year, but I think that's what I've missed. So, I'm going to be talking about bring your own spectrum rather than bring your own device. And what that means for private, but especially enterprise cellular networks, and why it's a bit of a game changer in various guises. I'm going to go through this quite quickly because it's the end of the day and there's quite a lot in here, but I'm around for drinks afterwards, so come and harangue me there. I'm also known as Disruptive Dean. I'm usually the person asking the awkward questions and also simultaneously tweeting. And I cover a bunch of stuff around mobile networks, regulatory policy, voice and communications and programmable telecoms, and bits of sort of random futurism thrown in for good measure. If I don't disagree with people and annoy people, at least at one level today, I'm not doing my job. So, first off, imagine in 8 years' time, you come to an event like this, and you're in your magical new self-driving car. Let's say that it's owned by you rather than an Uber. And you get out at the hotel or the conference venue, you walk in the door, and the car goes and parks itself in the car park. And the next day, or later that after the event finishes, you want to go and get picked up. So you get your phone out, and you say, come and meet me at the front desk or front lobby. But the problem is the car is now in an underground car park, 2 stories below the ground. And there's no mobile coverage. So the car can't get what you're sending from the phone. In fact, the car can't communicate with anyone or anything. It is effectively offline. And then the question is, whose responsibility is this problem? Is it the hotel owners? Is it the network, which the car is normally attached to? Is it your job? Is it the landlord for the building? Is it the investor who's living in a retirement home somewhere? Whose job is it to make sure that connectivity works? Now, for 4G and 2G and 3G, that's historically not been that much of a problem. You've had repeaters, you've had distributed antenna systems, sometimes even in the car parks. But for 5G, with the magical self-driving capabilities and ultra-reliable this and slicing the other, at least in theory, you're going to need to use lots of spectrum for your high-performance network, which almost certainly won't penetrate into the building even through a window, if it's millimetre wave, let alone 2 floors underground. And so, well, the obvious answer is the self-driving car will have to have enough onboard intelligence to park itself and drive itself. But, there's other scenarios here where you have the elevator engineer who's in the elevator shaft trying to fix something with an AR headset. All of these sort of scenarios you can build. And the point here is that there's lots of parts of buildings or rural areas or cities or metropolitan railway systems that are difficult to give network coverage to. And it's not clear how you solve that problem, especially in a world where you need every single carrier or operator, because each car may be on a different network. So that's just to give a bit of context of the type of problem that I'm thinking about here. Now, more generally, it's worth thinking about the huge future range of future wireless applications and use cases. Now, I've got to apologise for this chart. I could only get 6 dimensions onto a 2-dimensional slide. There were about another 10 dimensions, but I ran out of sort of creative ways to pretend that I could add them on. The point here is that there's some massive hypercube of speed, range, business model, importance, coverage level, however you want to do this. And also perhaps sort of, everything from intellectual property involved to geopolitical issues to security. Anyway, there's lots of complexity. And the answer is that there is no one technology, whether that's 5G, 6G, Wi-Fi, anything else, that will cover all of this. And also, what I put in the red is there's going to be different approaches to delivering spectrum. Now, at the moment, you have national exclusive licenses in most of the world, or regional, perhaps state by state, or something similar in the US and India and others, for the major cellular carriers. And you have unlicensed spectrum for things like Wi-Fi and LoRa and the various other industrial, scientific, and medical bands. But what we're going to is this thing where I put shared, which is where there's either secondary use of spectrum, dynamic spectrum allocations for certain places or certain times, or what is called sensed, where you're actually seeing if someone is using a particular piece of spectrum, and if not, then perhaps opportunistically you can use it instead. Now, that's a whole world of regulatory change, but the way in which we start slicing up spectrum as well as networks is going to change a lot. Now, some people here will probably say, well, can't we do everything with Wi-Fi? And the answer is you can do a lot of things with Wi-Fi, and I certainly think that, for today, Wi-Fi in normal carpeted enterprises is very good. For public venues where you've got fairly easy access and without you have cumbersome logins and having to send a SMS to a phone number in another country, IIT, where there's a simple way of using Wi-Fi, it's good. It's not great in industrial spaces because often they're large, indoor-outdoor mixed, and it's certainly not good for broad outdoors or rural. That's improving a bit with Wi-Fi 6 and Wi-Fi meshes, but it's still not ideal in some places. And you're finding that, for example, public spaces, Wi-Fi is actually getting worse because of these cumbersome log-on processes and privacy invading monetization. It's the bane of my life. So what we're seeing is that various other connectivity methods are better for some circumstances. Not in the home, I would say, but in some enterprise locations for some things, and certainly for industrial use cases, it's considerably better. And I think that what this means is, again, you're going to have a whole range of different wireless technologies in future, whether that's 4G, 5G, Wi-Fi, fiber, and so on. By the way, TSN, with a question mark, TSN stands for time-sensitive networking. In future iterations of 5G, a few years hence, you'll be able to get deterministic 5G, which behaves a bit like industrial Ethernet, at least in theory. So, 5G. Sounds great. Everyone raves about it all the time. But there's a bit of an issue. So, at the moment, you've got a few actors involved. You've got the mobile industry, which is the big vendors and the mobile carriers. You've got I'm particularly looking at the industry verticals and enterprises, which everyone is very keen on for 5G at the moment, and then governments and regulators. And so the conversation is going something like this. The mobile industry is going to government and saying, 5G is amazing, it's going to run everything, GDP will go up, social inclusion will go up, the world, it'll solve world hunger. Can we have less regulation, please, and more spectrum, ideally for free? What they're not saying, because, well, they're politicians, aren't they? They don't mention the fact that 5G is going to come in phases, and it's only really in the later versions that all the fancy ultra-low latency stuff really kicks in. They're keeping the message simple. And then to the industry verticals, they're saying, hey, 5G is going to be amazing. It's going to be able to do everything. We're able to run exactly what you want to do in your factories, on your farms, everywhere else. But what is it you actually do again? Sorry, I know you do this sort of industrial stuff, so can we set up like an organisation for 5G in industry or in cars so we can actually understand what it is we want to sell you? And if you've got any spare spectrum, broadcasters, we're looking at you, can we have that as well? And then what they're also doing is they're having a conversation with investors saying, we are going to make a ton of money out of enterprise. This is where the growth is going to come from. The problem is that the industry people can hear this. And they're like, so in other words, you want to sell us stuff which you think is going to be highly profitable, i.e. you're going to charge us lots of money for it. You don't really understand our business and you want us to tell you what we want. And if we've got spectrum, you want to refarm it and give it to you as well. We're not convinced by this. So what they're trying to do at the moment in some parts of the world is industry and verticals are going themselves to governments and regulators saying, you know what, why don't we cut the middleman out? Why do we need the telecom carriers anyway? Can't we just do this ourselves? After all, we've built Wi-Fi before, we've built IT systems. Maybe we can do it. Or we can engage with a managed service provider or systems integrator who can do it themselves. So there's this sort of dynamic that's going on. And this is a little bit stylized, and it's a little bit, it's end of the afternoon. The other thing which is going on, which is, hang on a second, if this is going to run the world really, that's an interesting security issue, isn't it? We need to check that all this works. Because if you're saying it's going to run critical infrastructure, then it is critical infrastructure, and so is the software running it, and so are the companies supplying it. Come and talk to us. So this is a bit of background. So what we're seeing, and it's partly driven by this and partly driven by a bunch of other factors around coverage I'll come on to in a second, is that there's various new sorts of network operator who are emerging. So collectively, these tend to get called non-public networks, NPN, because 3GPP had to come up with a new acronym that nobody understood. Private wasn't good enough, we had to call them non-public. And actually, what we have here is a few slightly different variations on the same theme. It's basically cellular networks that aren't run by traditional carriers. Private cellular is typically, we're talking about enterprises, and I'll talk about more about that going on. And that's either run by private companies or, as I said, by managed service providers for a particular vertical or location. Microcellular is, as the name suggests, cellular in a particular place. So it could be community cellular network for a village, or for even a smart city might run its own network. And so it's sort of quasi-public within a certain area. It could be an island or so on. And then neutral host is something that I talk about quite a lot with, and that's essentially a wholesale network, where there are a number of organizations that are building out cellular infrastructure, 4G or 5G, in areas that are hard to cover, either hard to get to or economically challenging. And they're saying, it's a bit like a tower company, but with the radio as well. And so that is becoming more of a possibility, and there's a few different delivery models there. And there are all sorts of sort of quasi-overlaps, so you might find that there are private networks being deployed in a factory, but they also have a sort of wholesale element for third-party operators or national carriers that want to operate in that facility. So there's a sort of the overlapping Venn diagram. So within enterprise, there's a whole set of use cases. Now, I'm not going to go through all of these, but there's a couple of things which are fairly normal. It's we want to have the outdoor cellular network work properly indoors. And 5G being, as I said, particular challenges because of the frequencies there. There's essentially plain vanilla, we want to have access to the internet for our employees and guests. That's roughly what we use Wi-Fi for today. There is sort of static IoT, which are things that don't move in certain places. So it's the air conditioning, it might be the projectors, it could be the building access control, CCTV cameras, these sorts of things. And that's, again, typically been Wi-Fi or maybe low-power, wireless, or frankly, a wire for a lot of use cases. The new categories, local mobile IoT, are connected things which move around. So robots, wearables, in industrial environments, you've got things called AGVs, which basically autonomous things like forklifts or trucks in factories. So those are particularly challenging. Could be cranes, could be construction machinery, could be tractors. Wi-Fi clearly isn't good enough there because they tend to go over wide areas. And we could use the carrier network if there is the carrier network. But if you're on a factory somewhere new or a oil rig or something like that, that's probably not an option. Then there's what's called OT. Who here is familiar with the acronym OT? One person, right. This is an interesting one. OT stands for operational technology. And that essentially is things like industrial machinery. It's things like production lines. It's things like actual equipment. It could be robots would count in a factory in an industrial automation setting. And the OT environment is basically those organizations that make the controllers, the flashing lights you see, and it could be a factory or it could be a dock or something else, which has got an embedded computer in it, but often they have all sorts of weird industrial protocols that are doing the networking. They probably have really, really hard real-time requirements and deterministic requirements on the networking. They may well not use IP. They may well use some weird wireless services that you haven't heard of, like wireless HART is something used in the oil and process industry. It's sort of quasi-Wi-Fi, but with a mesh component and more resilience. And it's essentially optimized for industrial environment. So that is a really interesting area for cellular in future, particularly the later versions of 5G. But the question is whether those are environments in which the cellular carriers are ideal providers. So we'll come back to that. And then the last one is sort of local voice and communications. A lot of people want to switch over their walkie-talkies and two-way radios, maybe using DECT or Tetra or P25 and things like that, over to using smartphones because of cost and flexibility and new data applications. So really here, there's lots of reasons for private organizations, whether those are small or large enterprises wanting their own cellular network. And when I say their own, it could be a sort of partitioned slice of a public network, or it could be something physically separate on their premise. And sometimes it's related to coverage, just because the public networks, if you have a wind turbine farm on the top of a hill, in a mountain in a remote area, there's probably no cellular coverage. Certainly if it's an offshore one. But also along road and rail, deep inside buildings, in tunnels, in mines, lots of locations where coverage is hard. But the main thing that a lot of enterprises want is more control. They either want more security, they want to have their data physically remaining on the premise. Some still don't trust the cloud, or if they do, they want it on their own infrastructure. They don't want it transiting the carrier's network. They may want to have things they can't do with Wi-Fi, like high density of equipment. I talked to someone who was the CIO of a set of hotels in Vegas, and they have, 1,000 gaming machines on the gaming floor, and Wi-Fi is quite challenged at that type of density of device deployment. But also they might want to have either time to market and deploy something really rapidly. Say if you're doing a construction site is also quite dynamic. You might have a cubic mile of dirt being moved if you're constructing an airport or something like that, and the radio propagation will change on a weekly or monthly basis. But also, you might be a railway company or utility, and you want to have a guarantee of a 30-year life on the network. You don't want to have to deploy 5G today and then have your carrier come around in 10 years' time and saying, you've got to rip it out and put in 6G. No, I want to have 5G today, and I still want it in 25 years' time. So there's a lot of interesting reasons why companies want their own infrastructure. And there's sort of cost. And actually, some of them have got some interesting new business models. So the same Vegas hotel was saying, we want to charge the national carriers to roam onto our network. After all, we're the same size as a small town. And there's plenty of small regional carriers. Hell, we can have 5,000 rooms. We could be one of those. So you pay for accessing customers on our premise. Then they went off and said, well, actually, we also quite like the idea of having venue-specific MVNOs. Maybe we can cut a deal with Instagram. So you have the Instagram network in the hotel. Or you do something which is oriented to Chinese or Japanese guests, where it's got language support or various other things. So how do you do this? Well, there's a bunch of technology enablers, but the three things that we're seeing. First is this transition from 4G to 5G. It's not wholly based around 5G, this idea, but it's catalyzing the discussion. And so it sort of correlates with 5G rather than being caused by it. Small cells are getting more cost-effective, better managed, more flexible, and also cloud delivery of a lot of the various bits and pieces of the network. So core networks delivered from the cloud, eSIMs, a bunch of other software components to building a network. And the last one is this thing, local spectrum models, or more spectrum available for enterprises. Historically, spectrum suitable for cell phones and cellular networks has been sort of said in national or very large area chunks aimed at a handful of carriers. There are now a bunch of ways in which it is becoming possible in different countries to get access to local spectrum, either at a county level or even at a small building level. This actually isn't new. The same general principle has been talked about for about 13 or 15 years. I did some work for a company in 2006 that was trying to get hold of a thin bit of spectrum in the UK and wanted to put 2G picocells. My client was made small sort of pizza box-sized core network boxes intended for enterprise usage. So this idea isn't entirely new. They wanted to create sort of PBX connected to a local cell network many years ago. It never really got deployed a little bit. The UK and Netherlands were really the only places that did this. But now, there's at least 5-10 countries, including US, UK, Germany, Netherlands, Australia, which have various means of getting hold of local spectrum. And in the US, there's this term CBRS, which I encourage people to look up, Citizens Broadband Radio Service. Basically, it's a chunk of spectrum at around 3.5 gigahertz, which is normally used by the US Navy for aircraft carrier radars. Don't get too many aircraft carriers in Las Vegas, so clearly you could, at least in theory, reuse that spectrum. That's just starting to become usable now, and over the next 18 months, that ecosystem is growing massively. The UK has come up with a number of different ways of getting access to local spectrum, small as a 50-meter radius, and I think the pricing starts at about $100 to get private spectrum on a localized basis for 10 megahertz spectrum. And there's potential to get much larger chunks and a mid-sized 3-kilometer radius one as well. The UK is also looking at it having indoor unlicensed 26 gigahertz for 5G as well. And we'll see what happens with 6 gigahertz. Germany is another very interesting one, where the main band for 5G in a lot of Europe is 3.4 to 3.8 gigahertz. And so what Germany has done, where you've got a lot of large manufacturing companies like BMW and Bosch and BASF, is they've decided that the upper 100 out of that 400 is going to be dedicated for this type of purpose for industrial networks. It's quite controversial. Originally, it looked like it was going to be very easy because Germany had 3 mobile carriers and 400 megahertz spectrum. So they thought, well, that's roughly going to work out as 100, 100, 100 with a spare 100 left over. Unfortunately, there was a fourth bidder in the auctions, which means that the prices went sky high, but that's a different story. And so there is this industrial ban in Germany. Sweden may well do something similar. The Dutch have been able to do a local licensing of 3.5 for a while. Australia has allowed sort of local licensing. So if you've got a mine in the outback, you can go to Telstra or Optus and say, can I sublease or sublicense, 20 square miles in the middle of nowhere? And that type of thing is certainly possible as well. So there's various ways of getting your hands on spectrum. This is why I call this bring your own spectrum. And I think that we're going to see more and more of this type of thing, certainly in developed countries. I'll see what happens in India. China is a bit of a special case, where I guess if you're China Railways, you've probably got as much sway with the government as China Telecom or China Mobile. But it's if you're a small company in Shenzhen, you probably don't. So this is at the moment it's very messy. It's a bit of a pain if you want to do this in 10 different countries. You have 10 different regulatory regimes and possibly 10 different spectrum bands or 8 different spectrum bands. But we're getting there. This is a massive change over a couple of years ago. So I've only got a few minutes, so I'm going to have to skip through quite a few of these. One thing to note is that talking about private cellular networks, there's lots of different levels of scale and scope here. It could be an individual office building or hotel, or even a ship with private network. So in fact, you can have a small cell on a private jet, I've heard of, which is that's a very small private network. Right up to national, where you've got utility companies and rail companies saying, we want to deploy our own network. It could be for the high voltage grid for a utility company. often they'll have fiber, but they might want to have cellular as a backup in case of an outage or a cyber attack or something like that. And in the middle, you've got sort of campus-size organizations like airports, which sort of look like a city in its own right. And we might see individual cities or counties deploying their own networks as well. So there's lots of sort of different levels at which private cellular can operate, and this will be a little bit dependent on the regulatory regime in each country as to sort of what the maximum and minimum sizes of these new innovative licenses turn out to be. One thing to note is this is hard. At the moment, you can't just buy a private cellular network like in a box the same way you would Wi-Fi. I've been talking about the spectrum and the small cells, but there's all these other bits and pieces and components. It's basically a carrier network, but designed for a much smaller organization. And you might find that some of these are delivered as cloud services, some will be provided combined together, but I keep finding extra ones. So the timing sync box. To run a cellular network, you have to have really good timing synchronization for the radio, which is another thing you need to do, particularly if you're if part of your network is beyond the line of sight of satellites and GPS. Core network, SIMs, you have to work out what are you going to do with numbers, roaming and interconnect if you don't want it to be an isolated island. Do not imagine that this is going to be completely simple. So there's various sort of approaches to doing it. This is from an organization called the 5G Alliance for Connected Industries, which is essentially 5G in manufacturing organization, and they've come up with some templates for how this can work either with purely private networks or using the carrier as a sort of a host, either to deliver a private slice of a network or to actually have a shared radio resource. There's lots of different permutations of what gets shared, where is the level of integration, and how complex and expensive it is, and how much you want to lean on a service provider rather than do it yourself. I'm not going to have time to talk about neutral host very much. Suffice to say, there's lots of different ways of doing this as well. This is the wholesale model I mentioned. The really clunky way is to basically just have small cells from each carrier in the country, put in a cluster, all backhauled to a central data center and break out to the respective operator cores. That's James Bodie's a small cell on the side of, I don't know if it's his house or the village hall, where you're essentially allowing the other operators to roam onto your network. And the car is at a UK testbed where they're running the prototype 5G neutral host. Actually, the car is actually a train, or it's supposed to emulate a train because it's driving at 160 miles an hour around a banked circular track and doing gigabit per second handover from cell to cell. So there's various ways of doing that. I should also say that fully private networks are not the only answer here. In some cases, as I say, you'll get slices of an existing carrier network, and some enterprises are actually looking at sort of today's MVNO model as well, that they either have their own MVNO or a third-party enterprise-centric provider. Timelines. Basically, there's been a few hundred isolated private cellular networks for a while for mining companies and oil and gas and public safety and remote railways and things like this, pipeline. What's happening now is that it's becoming democratized and industrialized because the spectrum situation is getting easier, and all of those other aspects like the core network, there's a lot more vendors, there's a lot more open source, there's a lot more cloud-based delivery of all those other bits and pieces. So I'm expecting sort of 2020 to really kick off. A lot of the world is looking at the US and CBRS as one of the leading lights of this new wave of dynamic bring your own spectrum, but also UK and Germany are probably leading that too. I'm expecting to see millimeter wave take a lot longer to come to market in this. It's initially going to be lower bands, partly because of coverage reasons and partly because that's what's available. And I think that what will happen over the next 2 years is you'll get a lot of those bits of complexity condensed into sort of inner-box size solutions. You'll find that system integrators and other channel partners essentially have something so that if you're building a new hotel in Las Vegas or wherever, it will be as not quite as simple to deploy as enterprise Wi-Fi, but possibly simpler than today's distributed antennas, indoor wireless solutions. We'll see how that works. And I think we're going to see quite a lot of innovation around these business models like the venue MVNOs. So, to sum up, I would say a lot of people in the telecoms industry, and mobile industry in particular, assert that 5G will drive the transformation of many industries. We hear this all the time. What you don't hear them say, or even realise, is that the first industry that gets transformed is the telecoms industry. And I think that this is the paradox here. This is the sort of elephant in the room, is that we're actually going to see some fairly normal-seeming markets where you've got large national or major carriers, a few tower companies and virtual operators move to this new world where there's a much more diverse set of organisations owning and running cellular networks, whether that's private enterprises. You might find there's an industrial, maybe Honeywell sets up smart building mobile and gets spectrum in different countries, neutral hosts, government, public safety, and they will use carriers perhaps to do the installation and maintenance the way they do today for PBXs, or they might sublease spectrum from them, or in some cases they'll get a network slice if that all goes to plan. We'll see. So, I managed to squeeze all of that into half an hour. Come and talk to me about neutral host. That's a gratuitous plug. But otherwise, thank you very much.
Excellent.
And one last thing is apparently the new version of PowerPoint has a new mechanism to do real-time live captioning, which I'm pretty sure it didn't do before.
Excellent. Thank you so much, Dean. Let's take just a couple of questions, and then we'll head off to the bar if you want to chat to Dean.
Two quick questions. If you could put up your last slide, I just wanted to take a quick pic of that.
This one?
No, the last one.
Oh, yeah, sure.
Yeah, that one. And I think I chatted with you on Twitter. I'm Martin O'Shield, Windy City SDR. We did a presentation before Bell Labs in June, and upon my presentation in June at Bell Labs, I was being offered 4G and 5G spectrum for last mile communities, and a lot of the stuff that you're covering, we're able to implement it on a live USB stick that will create a 4G to satellite network with nothing around us, essentially eliminating the carrier. And then on top of it, if you peer from wherever your data centers are located, then you just cut your monthly whatever bandwidth from your carrier. So there's some stuff I'd like to talk to you. We'll exchange cards.
Well, yeah, definitely happy to chat.
And then, any other questions?
Where does AWS, Amazon, and Google play here?
That's a really good question. And initially, Google is one of the SaaS providers for CBRS. Google, I've been on panel with a couple of Google folk recently, talking about Spectrum as a service. And so I think that at the very least, that Google wants to sort of have sort of Spectrum available, if not just Spectrum to begin with, maybe eventually we'll go to sort of almost like full mobile network as a service where you sort of set something up or automate it, and you apply for Spectrum license as part of that. But they're certainly keen on the dynamic spectrum and sort of utilization-based view of the world. Amazon is interesting. So Amazon is also involved in CBRS and is clearly interested in a lot of the other related things here. I have a suspicion that they may well try to do this as a sort of local network linked to their data centers for particularly IoT. It was interesting that they have an IoT, non-cellular, but like a sort of LoRa type thing they announced recently for low power wide area. And so it wouldn't surprise me if they start becoming a localized deployer of cellular in certain locations. My sort of long-held pet theory is they might do this from Whole Foods stores at some point, use them as an anchor point, but we'll see. But I
Excellent.
think both are.
Thank you so much, Dean. Well done.
Thank you.